Hello students, let us try to understand the Pearson concept of the acid base. So here is the Pearson classification of Lewis acid, Lewis base into hard and soft acid base concept. Okay. So that is R.G. Pearson in 1963 has classified Lewis acid, Lewis bases as a hard and soft acid and bases. A third category is whose characteristics are intermediate between those of the hard and soft acid bases are called the borderline acids or borderline bases. The principal characteristics of the hard acids and soft acids are based along with their examples are given in the table 19.5. So first thing is there Pearson hard and soft acid basis principle HSAB principle on the basis of experimental data of various complexes obtained by the combination of the Lewis acid and Lewis bases. Pearson 1963 discovered a principle known as hard soft acid and base principle, HSAB principle. Some chemists preter and the abbreviation HSAB instead of HSAB. Some chemists prefer the abbreviation of the SHAB instead of HSAB used by Pearson. This principle states that a hard Lewis acid prefer to combine with hard Lewis base. Similarly, a soft Lewis acid prefer to combine with a soft Lewis base. Since these type of combination give more stable compound, thus we can say that hard acid plus hard base and soft acid plus soft base combine to give more stable product than the hard acid soft base and soft acid hard base combination. The combination of hard acid and the hard base occur mainly through the ionic bonding as a Mg magnesium hydroxide Mg2 plus hard acid OH minus hard base, and that of the soft acid and soft base takes place mainly by the covalent bonding in Hgi2 Hg2 plus soft acid and I minus soft base. Okay, so let us have a look over the application of this principle. So HSCB principle extremely useful in the explaining following. First one is stability of the complex compound having the same ligand. Okay, so they are saying the application can be understood by considering the following example. Hgi2 minus, Hgi2 minus is stable while AgF2 minus is does not exist. We know that Ag is the soft acid, F ion is a hard base, and I ion is soft base. Since AgI2 is obtained by the combination of soft acid Ag plus and soft base I minus. AgF2 result by the interaction of soft acid Ag plus and hard base F minus. AgI2 minus ion is stable but AgF2 does not exist. Next one, see what is the how the classification has done here. So they are saying hard acid Arnold and Chet 1958 have arbitrarily called the hard acid as class A metal ion or metal acceptor metal ion or metal acceptors. Soft acid, these have been called class B metal ion or metal acceptor. Borderline, that is intermediate acid. They have the acceptors metal atoms and small size. They have acceptors with high positively charged oxidation state. The valence electron of the acceptor atom of these acids cannot be polarized or distorted or removed easily. That is, they have low polarizability since they are held strongly, and it is for this reason that these Lewis acid have been called hard acid or hard metal by Pearson. They have the acceptor metal atoms and large size. They have acceptor atoms with low and zero positively charged positive charge. The valence electrons of the acceptor atom, these acid can be polarized easily. They have high polarizability since they are held weakly. And for a reason, these Lewis acids have been called soft acid and soft metal ions, that is Pearson. The borderline are the characteristics of borderline acids are intermediate between those of hard acid and soft acid. If you talk about the example H plus Li plus Na plus K plus Be2 plus like that, here is Cu plus Ag plus Au plus, these are there, and borderline are there Fe2 plus Co plus NiCO. Okay. Next one they are saying the Lewis bases are there. They hard bases, the donor atoms are hard base. Soft base, the donor atom are the soft base. Has low electronegativity, has high electronegativity. These bases have the intermediate properties. Example, water, OH, ROH, R2O, RO. These are the high electronegativity. R2S, RSH, RS minus, SCN minus. They are low electron. These are the borderline. Okay. COF6 hard acid hard base is more stable than COI3 hard acid soft base. This is all about the HSAB principle.